Hi you guys, so let's do another video on graphing with transformations. This video is going to focus on graphing exponential, logarithmic, and to be more specific, rational functions. So let's get started with graphing the function g of x equals e to the negative 2x plus 1 minus 5. So for this function, we can tell where the exponent is on the e, so the e would be the base, and it looks like our variable for the function is in the exponent. So this would be an example of an exponential function. Furthermore, our base is e, so it's probably the most common exponential function that you will ever encounter. Okay, so let's take a look at identifying the steps of the transformation. And this is not in the correct order, but this is in the order of appearance. So our a, b, h, and our k. So looking at the coefficient in front of the base, we have a -1. That means that my a is -1. Looking at the coefficient on just the x, we see 2. So b is 2. Looking at the second term in the exponent, we have a +1. So when we see a plus, that represents a left shift. So I like to do, instead of worrying about minus plus, I just like to write 1 left for myself. And looking at the second term in the whole function, we have a -5, so that corresponds to a 5-unit down shift. Okay, so looks like every single kind of transformation has been applied. Now, when we graph this, we're going to start with the parent. So f of x is our parent function. That's usually the notation that I choose to use at the very least. So the parent function is what you would get if you deleted a, b, h, and k, essentially removing the transformations from this function. And what we are left with when doing that is we're left with e to the x. So our parent is e to the x, and that's going to be where our points come from. So I'm going to make sure to track at least 3 points on the function, and since this does have asymptotes, this parent function has an asymptote at y equals 0, I'm going to make sure to track the asymptote. So I'll do the asymptote part first, and since it's a y, I'll put the 0 in the y column. Okay, and then our points, I recommend for an exponential, just doing one to the left of the y-axis, and one on the y-axis, and one to the right. So then to get your y-coordinate, remember you plug them into the parent function. So I'll plug in e to the -1, which is 1 over e, and e to the 0, which is 1, and e to the 1, which is e. Okay, now tracking our transformations, I'm not going to go ahead and convert to a decimal at this point, because if I convert to a decimal, my calculator is approximating the numerical value, and it's going to force me to have to round, which is not a good thing. Because I have many different iterations of arithmetic to do on these numbers, I don't want to round 5 or 6 times. So I'm just going to stick to leaving it written in terms of e, which is something we're very commonly going to be doing in calc and beyond. So get used to writing e's in a lot of stuff. Okay, so starting with our first transformation, it goes h, b, a, k, leaving ourselves a nice amount of room. And for the h, okay, so for h we have a 1-unit left shift, which means that we're going to subtract 1 unit from our x's. So we get -2, -1, 0, and the y's stay the same. And then for our b, it's going to have the effect of divide the x-coordinate by our b value. So we're going to get -1, -1/2, and 0, and the y's stay the same. And then for the a, it's going to have the effect of changing our y-coordinate. So our y-coordinate is going to be multiplied by the a value, y times -1. Okay, and our y's are going to change while the x's stay the same. So we'll get negative 1 over e, negative 1, negative e. And now is when I'm going to start paying attention to my asymptote. So because my asymptote only affected the y coordinates as it is a horizontal asymptote, the y's were unaffected in the first two steps. So my asymptote is going to stay the same. However, in this step, theoretically, well, I guess since our asymptote was at y equals 0, it's not really going to be affected at this step. But since it's involving the y coordinate, it's a good idea to think about, would that change the asymptote? Since 0 times negative 1 is still 0, in this case, it did not change it. Okay, now we're going to do our k shift, which is a 5-unit downshift, and subtracting 5 from the y coordinate is what's going to give us that. So we're going to have negative 1 over e minus 5. Negative 1 minus 5 is negative 6, and negative e minus 5 is the last coordinate. Okay, now at this step, before we go ahead and plot this, make sure to notice that the asymptote does actually change. 0 minus 5 is negative 5. Okay, so it makes sense that if your parent had an asymptote, your final function will also have an asymptote. And I just like to check at this stage, did I do each of the transformations correct? Yes, looks fine to me. Okay, so let's go ahead and graph this. Okay, it looks like we have a lot of negative values, so I'm going to kind of position my x-axis up here. Just give me enough room to basically label it. And our x-coordinates that we're working at are at negative 1, negative a half, 0. So we'll maybe scale it like this. Negative 1. This is negative 0.5. Okay, and then we'll scale the y-axis at 1 unit. Okay. And I might even want to give myself just a little bit more room than this to graph it. It looks like that's going to be kind of close to the bottom of the graph. Okay, and now would be helpful to get a decimal approximation for those points, particularly negative 1 over e minus 5, just so that we have a handle on roughly where it is. So it's going to be somewhere between negative 5 and negative 6, about negative 5.5, but not quite, so a little bit less than negative 5.5. And looking at what that is equal to, use our calculator for that. Yeah, so negative 5.37. Okay, and then negative e minus 5. It's going to be negative 7.72. 1, 2, 3, 4, 5, 6, 7. We need just a little bit more room off the bottom, but I think that'll fit. Okay, so negative 1, we're at negative 5.37, so 1, 2, 3, 4, 5, and about a third. About there. And then negative a half, negative 6, about there, and then 0, negative 7, and 3/4, so about there. And then tracking our asymptote, this is where it's really helpful to remember where that is. I'm going to plot a dotted line right here. Okay, and I can see, I know what an what an exponential function does. It approaches its asymptote, and I can see which direction it's trying to approach. It's trying to approach this way. So this is why tracking the asymptote is particularly useful, is because it helps me kind of fill in the shape a little bit more, obviously. And then to be really nice, it's good always for you to go ahead and label your x and y axis. Give me a little, you know, equation there, just to make your sketch really accurate and labeled. Okay. And just double checking that this graph has features that give me enough of the shape. I can see at least 3 points. I can see a shape. I can see an asymptote. That's about the extent of the detail we need on this sketch. So let's go ahead and take a look at another kind of function. Let's do a rational function. So I can see my x is involved in the denominator of fraction, making this a rational function, and identifying my transformations. I see my a value. So if you want to see the kind of pattern for where A, B, H, and K are with each of the parents, I recommend jumping back to my Graphing with Transformations video part 1 on this channel. It's at about timestamp 9 minutes and 54 seconds that you'll see a slide where I go through this. But the A for this one would be -1. The B would be the coefficient on the x, which is 1. The h is going to be the -3 after the x, so that's going to correspond to, I see a negative, which means that it is a right shift. I prefer to write right versus just writing -3, a little more clear. And then the k is going to be 2 units up. Okay, and then tracking each step of the transformations, we need to start with points on my parent. My parent function for all of these rational functions in this form are going to be, they're going to have the parent 1 over x. So 1 over x is going to have 2 asymptotes to keep track of at x equals 0 and y equals 0. So x equals 0, y equals 0. And I'm going to make sure that, knowing that the parent looks kind of like this, I know that because, you know, I've studied these parents quite a bit, obviously. And again, if you go to Graphing with Transformations Part 1, you will see the parents where I have them graphed nicely with technology. You'll see that there's those 2 asymptotes there. So keeping that in mind, I really want to track at least, you know, 1 point on each branch, maybe more. So maybe, you know, plotting, I'll kind of go a little overkill and maybe do 2 points on each branch. So we want to go to the left of 0. We could go with -2 and -1. We could go with 1 and 2 just to kind of be symmetric about it. And then the y coordinates would be what we get when we plug it into our 1 over x formula, -0.5, -1, 1.5. And then we're ready to go. So starting with our h, it's a right shift, so we're going to do 3 units onto the x coordinate, and right away we see that our asymptote is our vertical asymptote is going to be shifted by doing that. So x plus 3 gives me 1, -1 plus 3 gives me 2, 1 plus 3 gives me 4, 2 plus 3 gives me 5, 0 plus 3 gives me 3, and the y's remain unchanged. Okay, and then for the b, it's going to have the effect of dividing the x coordinates by b, which in this case is 1. So I'm not really going to bother to do a t-chart for dividing something by 1 because really we didn't have a b transformation, to be honest with you, so unnecessary to do that step. So instead, the next t-chart that we're going to do is going to be the a step, and it looks like a, we did have a transformation, so the y's are going to get multiplied by -1. So we're going to have a half. 1, -1, -0.5, and the x's stay unchanged. And then the y, 0 times -1 is just 0. Okay, and then for the k, it's going to have the effect of adding 2 to the y unit. So y plus 2, and that's going to give me 2.5. Okay, that's an exact decimal, so it's okay if you write it as a decimal right from the start. The problem is when you have an e, that is a non-terminating, non-repeating number that's considered irrational, that's when you don't want to switch to a decimal form, because your calculator doesn't really even know it, to be honest. E has an infinite number of digits, and the calculator just rounds it, truncates it at like 8. Negative a half plus 2 is 1.5. And then the x's stay unchanged. And the y asymptote 0 plus 2 is going to be 2. Okay, so just taking a quick look, making sure that this looks good. Looks good to me. Okay, let's graph it. So it looks like I have a lot of positive numbers. Okay, 1, 2, 3, 4, 5, and at x equals 3 is when we have an asymptote. I'm just going to put those in first because it helps me draw these. So x equals 3, we have an asymptote. At y equals 2, we have an asymptote. And it's helpful to note we're going to go ahead and scale it like that with 1 unit. So now let's plot our points. At 1, we're at 2.5. At 2, we're at 3. And at 4, we are at 1. And at 5, we're at 1.5. Okay, so I can see, knowing the shape of the original, just directing you back to what that looks like, I can see where my branches are going to be, and I can fill in. I know that it approaches asymptotically to y equals 2 and x equals 3. There should not be intersections because there were no intersections with the parent. So it's careful to note that when you apply transformations, you can shift left and right, you can stretch up and down, but in doing so, you're never going to all of a sudden cross an asymptote. So it's definitely important to track the asymptotes and reflect that on your picture. Okay, so labeling my asymptote, we've got our function, and it looks good. Okay, so let's do one more example, and let's take a look at logarithms. Okay. Actually, let's go ahead and do ln because ln tends to make people feel a little bit more uncomfortable. So let's go ahead and graph with transformations, natural log of 5 minus x plus 1. So I'm going to go ahead and start with finding my ABHK. It looks like the a is a coefficient on ln, which would be 1 here. The b would be the coefficient on the x, which is -1. The h would be the other term in the argument of my function ln, which would be, looks like it's positive, so it's going to be a 5-unit left shift, and then 1 unit up for the k. Okay, so let's note that you could have rewritten the argument like this if you prefer to look at it like that. Some people really do, and that helps them. Okay, so then our parent function is what we would get if we delete the ABHK, which would be just being left with ln x, the natural log of x. This notation means my base is e, and most people, they don't like e in pre-calc because they're just not used to it as much, but it's going to be your favorite number in calculus for a lot of cool reasons. So the points on the parent, make good choices. Don't choose numbers that are not powers of the base. So if my base is e, when I think about x values, I want to think about things in terms of e's. What are some easy powers of e? I think that e to the -1, I think that e to the 0, and I think that e to the 1 are all easy powers of e. So the x values that I'm going to choose are 1 over e, 1, and e, because I can see all the powers applied to my exponential. Okay, so now computing the log is easy because log just asks the question, what power? So the power on 1 over e was -1, the power on 1 was 0, the power on e was 1. So moving on, we need to keep track of our asymptote. I know that a logarithmic function has exactly 1 asymptote, and all the parents have their asymptote at x equals 0, which is the y-axis. So x is 0, y is independent. So now we're ready for our h transformation. H is going to have the effect of a left shift, which means the x coordinates get smaller, so subtract off 5. And again, I'm going to leave myself a little room here because we need to write 1 over e minus 5. 1 minus 5 is negative 4, and e minus 5 there. Y stay the same, and x shifted from 0 to negative 5. Okay, and then for the b, x gets divided by negative 1. So switch the signs on all terms. So 5 minus 1 over e, 4, 5 minus e, 5. And then for our k will be the next step in this transformation because A, there wasn't a transformation that was applied. The y coordinates are going to shift up 1, so it'll be y plus 1. So negative 1 plus 1 is 0, 1, 2. And then all the x's stay the same. Okay, so if we go to our final t-chart, be helpful to have some decimals in mind. 5 minus e would be about 2.28. And 5 minus 1 over e is going to be 4.63. And okay, ready to graph. Now we'll go ahead and, actually, sorry, I thought I noticed a mistake, but I think we're good. I'm just checking everything over again. It's always a good idea to check before you graph. No, we're good. Okay, so now moving on to the graph, it looks like we need mostly positive x values and positive y values. So I'll probably center my axes a little bit off-centered again, just to make it fit a little more conveniently. So we need to go to about 5 in the x direction, and we need to go to about 3 in the y. Scaling, and then okay, so at 4 we are at 1, at 4.63, sorry, 4 we are at 1, 4.63 we are at 0, here, and then at 2.28 we are at 2, so about 2 1/3 we're at 2, and then it looks like we have an asymptote happening at 5, x equals 5. I'm going to label my asymptote, and I have my scale and my axes labeled, so this looks like a good sketch. Okay, just a note before we end this video, let's look at the types of asymptotes that we have. Logs go with vertical asymptotes. That is an always thing because all logarithms have a problem happening at x equals 0 and to the left. All rational functions have both a horizontal and vertical asymptote happening at x and y equals 0. And all exponentials have a horizontal asymptote. So if you start with an exponential, your final answer should have a horizontal asymptote. If you start with a logarithm, your final answer should have a vertical asymptote. And that's because transformations don't change asymptotic behavior. Anyway, I hope this was a helpful part 2. And again, if you haven't gotten a chance to see the basics of graphing with transformations, I strongly recommend you go back to my graphing with transformations part 1. And I will see you guys next time.